Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to be taking a look at the power rule, another tool that you can use when you need to do differentiation for derivatives. So let's go ahead and take a look at this. So imagine that we have the following that we need to try to deal with here. We're trying to address this following guy right here. So let me go ahead and pull up my, okay, here we go. So we're trying to find the derivative. And this is kind of an alternative way to draw derivative, d of x. This is another way of just saying, f prime or whatever, of x to the fourth. And so first we're going to work this out using the limit function. So it's going to equal the limit of h approaching 0. And so when we plug this in, again, I'm assuming you're already familiar with the limit function and how you can use limits to calculate derivatives. So that's going to be as follows. It's going to be the limit of h approaching 0 of x plus h to the fourth power minus x to the fourth power, all this over h like so. Again, these are things that we've talked about in the past. Now, what we have to do now is we have to expand out this. Now, again, we don't have time to reteach this, but it's going to involve the binomial theorem and Pascal's triangle. And so when you do all that, again, no time to teach everything every single time, you're going to get the limit of h approaching 0 of, and this is where it gets long and complicated, you got h to the fourth power plus 4h to the third power, 4hx, 4h to the third power x, that's what I wanted, plus 6h squared x squared plus 4hx to the third power, continuing here, plus x to the fourth power minus x to the fourth power, all this over h. All right, so there are a few things we can do right now to make this a little bit simpler for us. Number one, we can eliminate this positive x to the 4 and this negative x to the 4, they kind of cancel each other out. And so now we're left with the following. This is where it continues to get difficult here. Limit of h approaching 0 of, draw this nice long line here. We got h to the fourth plus 4h3x plus 6h squared x squared plus 4hx to the 3, all this over h. And so now what we're going to do now is we're going to factor out the h, and we end up with the following. So we're going to factor out an h. Let's see here. Okay, so now we got the limit of h approaching 0, and now we're going to have this h on the outside, like so, h. And then inside parentheses, h to the third plus 4h squared x plus 6h x squared plus 4x to the third, 4x to the third, like so, all this over h. And so you can probably tell that these are going to cancel out right here. I need a little bit more space. And so now I have the limit of h approaching 0, and it's going to be worked out as follows. H to the third plus 4h squared, 4h squared x plus 6hx squared plus 4x to the third. And now there's no more denominator because it canceled out. Now we simply plug in h for 0, so we put in h equals 0 because that's all that's left. And so everything cancels out here. So we got h to the third is going to be 0 plus 4h squared, that's going to be plus 0 plus 6hx, well, we got another 0, and then plus 4x to the third. And so essentially our answer is going to be 4x to the third. Now that's the long way to solve it, and it kind of gives you the proof for how it works out. But in simple terms, what you can essentially do when you're trying to address one of these situations is as follows. Whenever you have the derivative of a value of a particular variable or equation where it's x to the n, it essentially equals the following. You're going to have n, whatever it is, you're going to bring that in front, x, and then you're going to have n minus 1. Now, in case you forgot, and it's been a while, we started with x to the 4. And we ended up, if you look over here, with 4x to the third. So what happened was simple. We essentially took the 4 and we put it in the front like this. Then we have our x, and then we did 4 minus 1 or n minus 1, and we got 3. So this is the shortcut for what we were trying to do, and all the steps we did before that is kind of how you work it out the long way so you can understand what's going on. So now that we know this, let's just do one basic example where we do this from the beginning. So we want to know, we want to know the derivative. So we got f of x, here we go, equals x to the 7, and so the derivative of this is going to equal, if you bring down the 7, it's going to be 7x, and if you do 7 minus 1, which is n minus 1, it's going to be 6 like that. And that is essentially the answer when you're using the power rule, which is a great shortcut for when you're trying to find derivatives involving exponents. So let's go back and review what we talked about and then wrap up this video. In this particular video, we learned how to use the power rule for when we're trying to deal with finding a derivative that might have an exponent in the original equation. And so at first we worked it out the long way with the limit function and canceling out the various terms that we're going to have in order to do this. So you expand the binomial. You expand the binomial so that you can work it out, and then after you expand the binomial, it's just a matter of working out the various steps of the factoring and canceling out the terms until you get with something that you can work with. And then once you are done factoring everything out, you just plug in 0 wherever there's h at, and there's always going to be one term left over at the end that is going to be the actual answer. But the shortcut to doing this is found where you take the exponent, move it down in front as a coefficient, and then for the exponent above, you just take the exponent minus 1, and that'll also give you the answer. The only problem with doing it this way is that you don't know why that's the answer and how it works. And so we did the longhand version first so that you know where this comes from, but in general, you're going to stick to the shortcut that is shown right here. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for listening, and we will talk to you later.